the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hello viewers, welcome to this platform. This is a revision platform for final year students of senior secondary school and high school, as is referred to in other climes of the world. Today we shall be considering a very important concept in chemistry known as water of crystallization. At the end of this study today, you are supposed to know the meaning and the definition of the following terms: efflorescence, deliquescence, hygroscopy, drying agent, desiccator, and the application of this concept in chemistry and in industry. Water of crystallization is a definite amount of water molecule associated with one molecule of a salt. This water of crystallization determines the structure and the color of salt. For instance, copper 2 tetraoxosulfate 6 salt pentahydrate, which is hydrated, is blue and crystalline, while the anhydrous form of copper 2 tetraoxosulfate 6 is amorphous and is colorless, is amorphous. Now, other examples of water of crystallizations are as follows. We have iron 2 tetraoxosulfate 6 heptahydrate. We have cobalt 2 chloride pentahydrate. We have magnesium 2 tetraoxosulfate 6 heptahydrate, also known as the Epsom salts. Now we also have sodium trioxocarbonate 6 salts decahydrate, trioxocarbonate 4 salt rather decahydrate. And we also have copper 2 tetraoxosulfate 6 salt pentahydrate. These are examples of salts that have water of crystallization. Now, what is efflorescence? Efflorescence is the ability of certain salt to lose definite amount of water molecule to the atmosphere. Example of salts that exhibit this quality is sodium trioxocarbonate 4 decahydrate. It loses 9 water molecules to the atmosphere. Now, this is the equation of the reaction. This is sodium trioxocarbonate 4 decahydrate losing about 9 water molecules. Now, to form sodium trioxocarbonate monohydrate. Now, this is a typical example of efflorescence. Now, what is deliquescence? Deliquescence is the ability of certain substances to absorb moisture from the atmosphere and turn into solution. Example of substances that exhibit this quality are: 1, we have sodium hydroxide, or also known as the caustic soda pellets. We have potassium hydroxide pellets as well. We also have calcium chloride. We also have magnesium chloride, silica gel. We have iron 3 chloride. These are examples of substances that, upon absorption of moisture or water from the atmosphere, turn into solution. Now, what is this term known as hygroscopy? Hygroscopy is also similar to deliquescence, even though there are slight differences. This is the ability of certain substances to absorb water or moisture from the atmosphere. Now, when they are solid, they become sticky. But when they are semi-solid, they become liquid. Now, example of substances that are hygroscopic in nature are: first, we have quicklime, also known as calcium oxide. We also have concentrated H2SO4 or concentrated hydrogen tetraoxosulfate 6 acid. These are hygroscopic substances. They are found applications in industry and even in analytical chemistry. Now, what is this drying agent? These are substances used to keep moisture away from substances in the laboratory. They are used as drying agent. These are used as drying agent during laboratory preparation of chemical substances. Now, example of substances that are used as drying agent can be either deliquescent, they can be hygroscopic. Any deliquescent substance and hygroscopic substance can be used as drying agent. However, it is important to note that choosing a drying agent, the drying agent must not react with the substance intended to be dried. Example of the commonest drying agent used in the packaging of pharmaceuticals is silica gel. If you pay attention to most of your pharmaceuticals, when you open them, you're going to see a packaged substance there known as silica gel. This silica gel, the essence is to prevent moisture from getting into the packaged substance. Now, application of this concept in analytical chemistry and industry. White anhydrous copper 2 sulfate turns blue in the presence of moisture. This is important in identifying the presence of water. Blue anhydrous copper 2 chloride pentahydrate turns pink in the presence of moisture also. This is also important in the identification of water during analytical chemistry. Now, possible exams in conclusion, exam questions. Possible exams or exam questions to be given from this concept are: is it proper to use tetraososulfate 6 acid to dry ammonia in the laboratory preparation of ammonia? If yes, why? If no, why? What is the difference between drying agent and dehydrating agent? What chemical compound is appropriate for drying ammonia during laboratory preparation? I believe you enjoyed this class. Thank you for listening, and meet you some other time. Goodbye.